In example 1, they've given us a graph of the velocity as a function of time. Now this is different than some of the graphs we've seen in the past where we have distance as a function of time. In those cases, we were able to look at the function and determine that the slope of that function gave us the velocity. But now we've plotted the velocity as a function of time instead. What can we do now in order to find out about some of the other characteristics? First of all, what if the slope here, if the slope of the distance function gives you the velocity because it's the first derivative, what does the slope of the velocity function give you? Acceleration. Because acceleration is going to be equal to acceleration is equal to the derivative of velocity with respect to time. That's the first derivative. Now that's also the second derivative of x with respect to time. So a equals dv dt, or the second derivative of distance with respect to time. So we're going to look at a couple of questions that have to do with this. Actually, we're going to look at several questions that have to do with this graph. And so let's look at the first one. When is the particle moving at a constant speed? Let's look at the graph. It's moving at a constant speed when the slope is equal to 0. In other words, the acceleration is 0, or the function is a horizontal line. So we can see by inspection of the graph that on the interval from 0 to 1, we are moving at a constant velocity. So that's going to be when that's going to be when the acceleration is equal to 0. And of course that's dv dt, or the slope of the velocity function is equal to 0. So when does that happen? It happens when 0 is less than t is less than 1. All right, and number 2, it says, when is the particle moving to the right? Well, that's going to happen when the velocity, when v of t is greater than 0. Because if the velocity is positive, it's moving to the right. Let's take a look. So when is the velocity positive? Well, in this graph, the velocity is positive when the function is above the x-axis. And so that happens on the interval from 0 to 2. 0 less than t less than. Now, number 3, when is it moving to the left? Well, it is moving to the left when the velocity is less than 0. So let's look at our graph. So where is velocity negative? Where the function is below the x-axis. So on the interval from 2 all the way to 5.